Hello friends, welcome to my YouTube channel Computer Science Classes by Nikhil Srivastava. And in this video we will continue our discussion of virtual functions and polymorphism. And this is exactly what we have done till the previous video. If you have not gone through the previous video, then please go through it. So we have created a class animal, and then we are deriving a class dog through the animal class. And then we have declared this function virtual, the dog, the sleep method in the animal class. I have declared it to be virtual. So once you declare the virtual is a keyword that is, that is declared in the base class. So once you have declared a function virtual in the base class, then when you override the function in the derived class, you do not need to write that keyword virtual. Okay, it is automatic. The function is automatically considered to be virtual. Okay, so now let me do one thing. I will create in the class, and that is the, suppose I say the cat class. Okay, so this is the cat class, and cat is also an animal, so I will write something like cat is sleeping, and then in the eat method I will write cat is eating. So now I have created two classes that are inheriting from the animal class. So this is just to show you the power of polymorphism and virtual functions. So how do we let me create a pointer for the base class. And what is the base class? The animal class. I have created a pointer p for the base class. Now let us create an object of the dog class, suppose d1, and then create an object of the cat class, suppose it is c1. Now if p is pointing to the address of d1, okay, p is pointing to the address of d1, that means it is pointing to the dog object. Then if I call the sleep method, okay, then if I call the sleep method, so you see the sleep method is overridden over here. If you observe, the sleep method is overridden, and the sleep method is virtual. Why? Because in the base class I have provided the keyword virtual. So again, what will follow for this, the point that will follow for this is that something like this: when the overridden method is virtual, then the call to it will depend upon the type of object. So here if you observe, the sleep method is virtual and the call to it will depend upon the type of object. So what is the type of object that is p pointing to? It is pointing to an object of the dog class. That is why if I run this application, then what will be the output? The output will be dog is sleeping. Okay, clean and build the application. And then once when you go and run the application, see, dog is sleeping. Now let me do one thing. Let me do something like this. P is equal to address of, say, suppose the cat object, and then once when I call p arrow sleep method, then what will happen? Interesting, huh? So if I again clean and build this application, and then once when I run this application, you can see what is the output. See, dog is sleeping and the output is cat is sleeping. Why this kind of output? See, call to overridden virtual function is decided by the type of object. So here p is containing the address of d1. That is mean it is containing the object address of a dog object. So here the p arrow sleep method, the overridden sleep method belonging to the dog class will be called. Now I have said something like this: p is equal to address of c1. That means p is containing the address of a cat object. So once when I call p arrow sleep, that means it will call the sleep method that is in the cat class. Okay, so that is why the output will be something like this: the cat is sleeping. In any case, if I try to do something like this, suppose p arrow eat, and here also suppose I say p arrow eat. If I call the eat method, then what will be the output? I think this is all we have discussed in the previous video also, but still it's always good to revise some concepts so that you have solid understanding. If I run this application, then what will be the output? So the eating method of the animal class is always called. Why the eating method of an animal class is always called? Because of early binding over here. Why? Because eat method has not been declared to be virtual. Okay, eat method has not been declared to be virtual. Alright, so this much is clear. And now the point which I want to bring up in your notice is that You are using a base class pointer, and base class pointer can point to a derived class object, but we can also use base class references. Okay, like we use base class pointer, we can use base class references. So what will I do? I will first of all I will comment out this code. Okay, I have commented out this code, and now I will create a function. I will create a function in the global scope that is taking a reference of type animal. Okay, that is taking a reference of which class? The animal class, and inside the method just the sleep method is being called. Okay, so this is different from pointers. When you access the member variables and functions through pointers, you use the arrow operator, but when you use the references, then you use the dot operator. Now I will just remove this also. Now if I create an object of the dog class, okay, I do not need to create it because I've already created it. Okay, yeah, fine. Now I'll remove this. Alright, and now I have two objects. One is the one is the dog object, and then second is the cat object. Now suppose I call function 1 and I pass the dog object. So this dog object is being passed to the function 1, and that is being collected in a reference. That reference belongs to the animal class. That reference belongs to which class? It belongs to the animal class. And see what I have written over here. In C++, base class pointer or reference, okay, can point to a derived class object. So that means the same work we can do with references also. So here, when I call the function with the object of the dog class, and when I call function 1 with the object of the, say, suppose the cat class, then what will be the output? Inside both of them, I am calling the sleep method. I am calling the sleep method. So let us see what is the output. If I clean and build this application, and then once when I go and run this application, let us see what is the output. See, dog is sleeping and cat is sleeping. That means the specific version within the dog class and the cat class was called. So this proves my point that you can achieve polymorphic behavior through base class references also and through base class pointers also. So the pointers we already saw, but now we create base class reference. How? Animal class, we created a reference of animal class, and then base class reference can point to derived class object. So dog and cat class are derived from which class? They are derived from the animal class. See over here, the cat class is derived from the animal class. So I pass a dog object, and this is being collected in the animal reference. Why? Because base class reference can point to a derived class object. Okay, and depending upon the type of object, not the type of reference. See over here, the type of reference is of animal class, but the call to overridden virtual function is decided by the type of object. So depending upon the type of object, the specific version of sleep method is called. So when I pass the dog object, the sleep method of the dog object is dog class is called. Okay, thank you so much for watching my videos. In the next video, we will try to see what is exactly polymorphic behavior and how can write some sweet code that will show you actually how is polymorphism defined as one interface many forms. Okay, thank you so much for watching my videos. Please do keep on subscribing and liking for my videos.